All right, in Unit 7, we're talking about radicals and rational exponents. The learning targets for today, we're going to learn how to simplify a radical expression with and without variables. And then we're going to learn what a rational exponent expression is and how to simplify it with and without variables. So in order to be able to simplify a radical, the first thing you have to know is what are your perfect squares. So this list here is all what I would consider your perfect squares. And what that means is what two numbers that are the same multiply equal a number. For instance, 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. So what you're going to do, if you have a radical, like for instance, the square root of 20, you're going to take a look at this perfect square list, and you're going to say, what number is 20 evenly divisible by? But you want to find the largest number. So instead of taking my chart and looking this way, I actually take my chart and look this way, because I want to find the biggest number that it's divisible by. So if I kind of go down this list, it's obviously not, 49, 36, 25. It's not 16. 20 is not divisible by 9. Oh, but 20 is divisible by 4. So I'm going to break up 20 into the two radicals, into the square root of 4 and the square root of 5. It's still 20. I've just broken it up into two pieces. But now I can take the square root of 4 because the square root of 4 is 2. So I'm going to, instead of writing square root of 4, I'm going to make that a 2. And then I'm just going to bring down the radical, square root of 5. So the square root of 20 can be simplified to 2 times the square root of 5. Let's try another one. Square root of 24, I'm going to look down my chart, look down, not 25, not 16, not 9. Oh, it's 4 again. So I'm going to write this as the square root of 4 times the square root of 6, because 4 times 6 is 24. Once again, I'm going to take the square root of 4, which is 2, and then I'm just going to bring down the radical 6. And so my square root of 24 can be simplified to 2 times the square root of 6. A rational exponent is an exponent that is a fraction. The numerator, or the top part of the fraction, tells you what power you're going to raise the number to, and the denominator, or the bottom part, tells you what root you are going to take. So for instance, 50 to the 1/2 power, it says I'm going to take 50 and raise it to the first power, so that's still 50. But then the denominator says I'm going to take the square root of it. So it's the same thing as saying the square root of 50. So these are identical expressions. So if I'm going to simplify the square root of 50, the first step I'm going to do is I'm going to take this notation and write it into this notation, just because it seems a little bit more common to us. The square root of 50 can be broken down into 25 times 2, but the square root of 25 is 5, so this becomes 5 square root of 2. Now, if I have a number in front, I'm going to start the same way. I'm going to just, first of all, I'm going to ignore the 2 in front for a moment, and I'm just going to concentrate my effort on the 40 square, 40 to the 1/2, which is the same thing as the square root of 40. I'm going to look at my chart. I'm going to say what perfect square is 40 evenly divisible by, and once again, it's 4. So I'm going to write the square root of 40 as the square root of 4 times the square root of 10. But the square root of 4 is 2, so I'm going to rewrite it as 2. I'm going to just bring down the square root of 10. But I can't forget that I had this 2 out here originally. So I'm going to bring that 2 down, and I'm going to multiply it with the 2 that is already there. So 2 times 2 is 4, so my final answer is 4 times the square root of 10. All right, why don't you put the video on pause and take a moment and see if you can simplify these 4, and then we'll go over them. All right. Right, the square root of 12 can be broken down to the square root of 4 times the square root of 3, which simplifies down to 2 square root of 3. The square root of 54 can be broken down into the square root of 9 times the square root of 6, which is 3 square root of 6. You'll notice when I'm simplifying these, I tend to put the perfect square first because it just makes more sense to say 3 times the square root of 6 instead of the square root of 6 times 3. The 72 to the 1/2 power is the same thing as the square root of 72, which can be written as the square root of 36 times 2, which is 6 times the square root of 2. And negative 3 times the square root of 300 is going to be the same thing as negative 3 times the square root of 100 times 3, but the square root of 100 is 10. 10 times negative 3 is negative 30. So this simplifies down to the negative 30 square root of 3. Now we want to take a look at, well, all right, that was great. I now know how to simplify radicals with numbers, but what if we introduce variables? So what if I have x to the 8th? The easiest way to think of this is to think, well, x to the 8th is like having 8 x's underneath my radical. And in order to figure out what a perfect square is, I want 2 of them. So I'm going to separate this into groups of 2. So I have 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2. So I can take them out of the radical in a group of 2. So I have 4 groups of 2. So this would simplify down to x to the 4th. Let's take a look at x to the 5th. So once again, I'm going to have 5 x's underneath my radical. I'm going to look at how many groups of 2 I have. So I have 1 group of 2, 2 groups of 2. So I can take that out as x squared. But this last guy, I can't take him out of the radical because he has no buddy to come out with. He can only come out of the radical if he has a buddy. So this x cannot come out of the radical, so he'll stay underneath the radical. So the square root of x to the 5th simplifies down to x squared times the square root of x. Now let's put it all together. Let's do numbers and variables. And I tend to do these in 2 pieces. First I'll do the number, and then I'll do the variable, and then I'll put it all together. So the square root of 200 can be broken down to the square root of 100 times the square root of 2. And then I'm going to break that x squared down to x times x. Well, the square root of 100 is 10. I'm going to bring down the square root of 2. And I can take x out of the radical because they have a buddy, so I can only take 1 x out. And then the last thing I'm going to do is just rearrange this so that the radical or the square root is the last thing or furthest onto the right-hand side. So it'll be 10x square root of 2. Now let's try it with a rational exponent. So this again is the same thing as saying the square root of 32x to the 9th. Right? Those are identical statements. I can break 32 down into the square root of 16 times the square root of 2. I'm going to have 9 x's underneath my radical. The square root of 16 is 4. I'm going to bring down my square root of 2. And I have 1, 2, 3, 4 groups of 2, so I can take out an x to the 4th, but I have 1 x that has to stay underneath the radical. So I have x to the 4th times the square root of x. Now I want to rearrange these, putting the radicals together and bringing them furthest to the right. So I have 4x to the 4th, and then underneath the radical I have 2x. All right, again, why don't you put the video on pause and see if you can simplify these 3. All right, 54 breaks down to 9 and 6. I have 3 x's and 6 y's. The square root of 9 is 3. I'm going to bring down the square root of 6. I can take 1 x out of the group of 3, so I have 1 x, and then I have to keep 1 underneath the radical. And my y's, I have 3 groups of y's, so I can take that out as y to the third. I'm going to rearrange this and put the radical together. So I have 3x y to the third times the square root of 6x. Let's take a look at the next one. All right, if I break down all the pieces, 75 can be broken down into 25 times 3. I have 5 x's and 7 y's underneath the radical. Square root of 25 is 5. Here, when I have my x's, I can take out 2 groups, so I have x squared, but I have 1 here that has to stay underneath the radical. On my y's, I have 1, 2, 3 groups, and I have 1 that has to stay underneath the radical. Now, if I rearrange all of this, 2 times 5 is 10. Then I have x squared y to the third. And underneath the radical, I'm going to have 3xy. All right, let's try the last one. 3x times the square root of x, 18x to the fourth y squared. All right, so I can break 18 down to 9 times 2, and I have 4 x's under the radical and 2 y's. The square root of 9 is 3. I'm going to bring down the 2. I can take out 2 groups, so I have x squared. And here on my y's, I can take out 1 group, so I just have y. And if I rearrange this, I'm going to have 9x to the third, because 3 times 3 is 9. And x times x squared, remember this exponent is really a 1. And when I'm multiplying like bases, I add the exponents. So 9x to the third y times the square root of 2. If you have any questions, let me know.